Hello and welcome 4th and 5th graders. My name is Mrs. B and we're going to talk about science. Before we get started with the lesson today, I want to talk about two important things that I want you to take with you through the summer. Two things that I want you to think about to make you a better scientist and engineer are first, using your 5 senses. So use as many senses as you can all the time. So let's do a quick check-in. What is something that you see right now? What is something that you smell right now? How about something you are tasting or tasted earlier today or will taste later today? How about something that you're hearing? Something that maybe you're touching or feeling. So let's always have our 5 senses on to make sense of the world around us, to start to think about and explain the ideas going on, to be able to describe, collect information, collect data, collect numbers. Another important part of science is asking lots of questions. So let's start with a what question. What is a what question that you have right now? How about a what-if question? A when question? A how question? And then a why question. And as we're going through this lesson, make sure you have your 5 senses on and ready to go, and that you're thinking and asking lots of questions about what's happening. Today, our focus is going to be back on energy. And so first, we had a lesson a while ago about types of energy. And then we had a lesson that energy has 2 forms: kinetic, or energy in motion, and potential, energy that is stored. Today, we're going to focus on collisions. And collision is a type of energy transfer. And it's hard sometimes and unsafe to want to explore energy transfer because it's hard to work with heat or light, or maybe working with sound, chemical energy. We are going to focus today on mechanical energy, and mechanical energy has to do with parts, moving parts. And so maybe an example of a collision that would excite you is thinking about an explosion. Again, explosions are not safe and something that we can easily investigate. But if you think of an explosion, objects are hitting each other and they are transferring energy. In the case of an explosion, the energy transfer can be from mechanical or chemical to heat, to sound, to light. What we're going to focus on is creating collisions with everyday objects and things that we have in our homes to look at it from a safer perspective. And some things we want to look for, some effects of collisions. We could hear some sounds. We could see a change in direction of an object and the change in speed of an object. One of our previous lessons around energy was also around mass, how much of something we have, and speed, how fast something is going. Today, I want us to focus and concentrate on collisions, energy transfer, and speed, how fast things are moving. So let's start by looking at the objects that I brought here for us today. I brought a softball and a baseball. I'm going to try my hardest to have these 2 objects collide, create a collision, and I'm going to try to push them at the same speed. What do you predict will happen? Remember, it's really important also in science to have predictions, to have an idea, what do I think is going to happen? Let me investigate that. Let me look into that, explore and observe, and collect some information around that to make better sense about what's happening. So when I push these 2 objects towards each other, what do you predict will happen? What are some possibilities? They could come together and completely stop. They could come together and this could push this object in this direction. They could come together and this object pushes this object in that direction. They could come together and then push in the opposite direction. What do you predict is going to happen? Let's see. Ready? I'm going to try my best to have them move at the same speed. What did you see there? This object, which when I use my sense of touch, I feel that this is heavier than this object. So when I pushed them together, it appears that this stopped it, and they moved, for sure this moved in this direction, and this also moved in this direction. One more time. So this looked like it completely stopped and transferred energy to this. So what happens if this is not moving, and then I'm going to push this towards it? Will there be a transfer of energy? Yes. How about if I have two of the same object? So I have two tennis balls. They weigh about the same. I'm going to again try to push them at the same speed so that they come together and collide and there's a collision. What are some of our possibilities? They can come together and completely stop. One could push the other in the opposite direction. They could come together and bounce apart. What do you think is going to happen? Let's see. What I saw is that they came together, touched, and then moved in the opposite direction. Let's do that one more time. They stopped and moved in the opposite direction. And now they stopped completely, came together, rolled back, and stopped. What if I took the softball and the tennis ball? What do you predict would happen? Let's do that again. Is that what you predicted would happen? What about a baseball and a tennis ball? Ooh. So they both moved in this direction, as did these two. Why do you think that? Does mass have anything to do with collisions as well? So think about that. Next, I want us to think about ways that we can create collisions to make some observations. And what I did here is I found a couple of different objects around my house. I brought a magnet, different kinds of toy cars. They all weigh slightly different. I found some wooden blocks that I could stack up and have them collide into each other. I brought different sizes of cups and cans. And then I tried to be creative and I made this structure here. And it's supposed to be like a swing. So if you think of a swing on a playground, two triangular sides and then a straight part at the top. And I taped them together because that's what I had. And I'm taping them down to the table so that it stays in place. And I want to use this to create a kind of pendulum. So pendulum is when we take a piece of string, yarn, rope, and we attach an object with weight at the bottom. Here I have a washer. And a washer looks like a flat donut. I also found nuts and bolts. And maybe there's an object where you are that you could attach some kind of string or yarn to and then add some weight. I also have a magnet that I could attach the string to as well. And I want to think about how am I going to create collisions? And that's something that I want to challenge you with. Think about energy, different types of energy, different forms of energy, and now really exploring energy transfer. So for collisions, it's when one object hits another and we can see the energy being transferred. And the type of energy with collisions is mechanical in this case. So if I wanted to start with my pendulum here for my first part of my collision, I'm going to see what would be the heaviest. And I think the heaviest object would be this nut that goes with this bolt. Next, what's the next step that I would want in my collisions here? A series, one collision after another. That's the goal here. Do I want this to swing? And if it's in this position, we have potential energy, stored energy. And when I release it and it starts to swing, I now have kinetic energy or energy in motion. And I want this to hit or collide with another object. I have some cars here. I have some blocks. I'm going to choose the blocks. So I'm going to line up my blocks close to my swing, my pendulum here. And then I have to think about, well, where would I put this and where should it hit the block? At what position? Towards the bottom, towards the middle, or at the top? So I'm going to have to make some decisions about that, do some trial and error. I'm going to try to have it hit the block right close to the top. So I'm going to measure this out. See if I could get it to swing and hit at the top. Attach it here. Hope this works. If it doesn't, it's okay. I'll try a different setup. So I'm going to put some tape there to keep it in place. Or let me try to tie it on actually. I'm going to tie this on here. Okay. So I've tied it on. It's a lot longer than I thought it would be. But when I swing out, I hope it's going to hit it. So I'm going to move my blocks. And I hope it hits it right about here. That's my goal. Let me practice with one. Oh, I completely missed. I'm going to hold it here. Okay, so I think I got a good spot. Right about here. Next, I want that block to hit this block. And then this one, and then I would like it to move this car, to hit this car. Let's see if I can make those collisions happen. Ready? Oh, it's still too far. Okay, so far so good. Then maybe I could have it move another car. I could have it roll this can. So think of how one object hits another, causes another object to hit another object. So think of a series, steps that you can take to observe collisions. I also brought this tube here, and I didn't have an object that would fit in it quite right, so I rolled up some aluminum foil. And maybe this is another way that I can get my objects to start to hit each other. So I would need to figure out at what height here and what angle would I put this tube to get this aluminum foil ball to hit my blocks, collide with them. So I would need something this high. My cups are not high enough. So what other objects do I have that I could use? Can I somehow create a pendulum with a magnet that maybe attaches to this can, or maybe the can becomes part of the pendulum and it swings, it comes back, and then it hits maybe the blocks, or it hits one of the cars, it rolls one of the cans. Maybe as you're doing this, you're going to hear some sounds. You're going to see a change in speed depending on the objects you're using, maybe a change in the direction the object is moving. So today our challenge is to think about energy and how energy transfers from one object to another with collisions. And again, as we were exploring the different objects that I brought, the different thinking around how am I going to create collisions, what objects will I use, what order will I put them in, ask lots of questions. What's a question for you that came up that starts with how? Or a why question? So I'm really glad you were able to join me today, and I hope you have a great summer and continue to learn and explore the world around you and do lots of different experiments where you are. Be sure to stay safe. And I also want to thank all of the grown-ups who are helping students to continue to learn to stay safe and healthy. And until next time, I hope you have a great day.
Hi, mathematicians, and welcome to At Home with APS. We are so glad to have you today. I am Mrs. Sears, and I'm going to be working with you today on something that we haven't tried before. It's actually a different kind of puzzle. Maybe you have, in the past, done puzzles like a jigsaw puzzle, or maybe you've done a crossword puzzle, or maybe you've even done a tangram, which is also a puzzle. It's kind of putting different geometric shapes together to make pictures or other things. Well, this puzzle is called a Ken puzzle. And what it is it's an actual puzzle for, it's set upon a grid. In this case, it's set upon a 4x4 grid. So what you can notice about this Ken puzzle is that there are some things that are different than any different puzzle that you may have seen before. First of all, because it is a 4x4 puzzle, you're only allowed to use the numbers 1, 2, 3, or 4 inside the puzzle. Okay, you cannot duplicate any of those numbers in any of the rows or the columns. What's also different about it that you might notice is that there's some operations on there. We're seeing subtraction, multiplication, addition, division. And what it's sort of like is it's kind of like a logic puzzle where you're trying to use your mathematical skills. So it's a little bit fun to figure out how and what it's asking you to solve. But you're also using your logic, your reasoning about how the numbers are going to be, and you have to be a little bit strategic into where you're going to put each of these numbers so you don't repeat those same numbers. Kind of cool, huh? So let me explain how this is going to work. The first thing that you got to know is that a Ken puzzle is made out of different cages. Okay, these little sections that you can kind of see in the certain color bands, like this one is going to be with a 3 and you see a minus sign there. The 3 is the target number. That's the number that you're trying to get between these two sections inside that cage. The operation that you have to use to get 3 would be the subtraction sign. So when you're thinking about that and knowing that I only have to use numbers 1, 2, 3, or 4, I've got to think about how could I get 3 using just those numbers? Well, the two numbers that come to my mind are I'm going to have to use a 1 and a 4, right? In some way, shape, or form. Now, it doesn't have to be that it's stacked upon it, you know, like we normally see when we're doing subtraction. It could be just within that different section in that cage that you would have those two numbers. But remember, you can't repeat those numbers in any of the rows or in any of the columns, okay? All right, one other thing. You get a freebie. A free cage or a free space is going to be the one that is denoted by just a number, but no operation. You always want to do that one first. This is like the bingo card, you know, and when you have the free space in the middle, and you go ahead and you put that one in right away. So let's go ahead and do that. All right, so the first one I'm going to do is I'm going to always complete my freebies first. So I can see I have a 3 here that's a free space, and I also have a 3 here that's a free space. Now remember, I cannot use that 3 again in this column, nor in this row. So I've got to be a little bit strategic in the next section of what I want to be able to do. And I think I'm going to do the 6th one next, because I already know I have a 3 over here. So I cannot use the 3 again, but I know to make a 6, I only can use the 3 and the 2. The 3 times the 2, because that's the operation that I'm asking to use. The 3 times the 2 is going to be the only thing that can make the 6. So I definitely know this has to be a 2 because I cannot put that 3 in that same column. Okay? So I know I'm going to have to put that 3 there. What do you think I should do next? I was actually thinking maybe I ought to go down a little bit because, again, I'm going to try and use what I already have, pieces that I already have closer together so that I can kind of solve those other cages first. So if I did this 3 plus, so that means I've got to make 3, but I've got to make 3 using only my numbers 1, 2, 3, or 4. What 2 things are going to make 3? I can't do 3 and a 0, and I already have a 3 there. I'm going to have to use a 1 or a 2. Well, I have to think about, like, I already have a 3 in this section. I don't quite know what might be happening up here, but I know in order to get a 3 again, and I have to use subtraction, I'm probably going to use a 4 and a 1. So I'm guessing a 4 and a 1 are going to go up here somehow in some way, shape, or form because I cannot duplicate those numbers. So I'm just going to take a hunch, and I'm going to say, let me put a 2 there. And what plus 2 makes 3? A 1. All right. Now, can I already figure out what my last one in this row is probably going to be if I did that? Let me try it. Let me just see if that 4 will go there. Because remember, I cannot use those numbers again. So if I'm thinking about going here next, because I'm really trying to think strategically in how I'm figuring out this puzzle, maybe if I went here next and I thought about, okay, I have a 2, I have a 3, I have a 2 and I have a 3. I know that I have to make a 3 again, and I know that I can use a 1 and a 4 to do that. So where that 1 and that 4 is going to be is kind of a question mark for me. But I'll have that top row completed when I do. I'm going to bite the bullet and I'm going to say, I'm going to try a 4 there, and I'm going to try a 1 here. Now again, I have this row completed and this row completed, and I'm just trying to think of what do I want to do next. Maybe I'm going to try some division. So I know in division, I have to think about, like, I have to come up with that target number of a 2. Now, if I divided 3 by 1, that's going to be a 3 because anything divided by itself is still going to be that number. If I did a 4 divided by 1, that's also going to be the same number, but I didn't notice I already have this 1 in this column. So if I have a 1 in that column, I can't even use the 1. So I'm going to have to use something like a 4 and a 2, right? Because 4 divided by 2 would actually be 2 because 2 times 2 is 4. You can divide that 4 in half. Where could I put it? Well, I haven't got anything in this row yet, nor have I got anything in this row yet. I'm going to take a guess again. I'm going to try that 4 there. I'm going to try that 2 there. Now I have this column done, this row, and this row. Let me see where I should go next. Oh, well, I have to go over here. I'm going to go over here because I haven't figured that out yet. I knew that 4 had to go there. So if I did the 2 with a minus sign, what would be 2, the target number, if I had to minus it from 4? Well, it's got to be a 2, which leads me to believe this has got to be a 1 if I'm doing everything correct. And now I need to figure out what's going to happen here. Oh, this is another 3 minus, right? So I'm going to have to put a 4 in here because 4 minus 1 is that 3. Now we have to figure out a 4. We can't do a 2 and a 2. We definitely need a 3 and a 1, but which way would the 3 and the 1 need to go? Well, I can't put the 1 here because I already have it there, so this must be a 3. What number am I missing here? I'm missing a 1. Let's see if that worked. Remember, the object of the puzzle is to be able to use all of these numbers without repeating them. Let's see if we did that. I did 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And let's look down. 1, 2, 3, 4. Yeah. 1, 2, 3, 4. Good. 1, 2, 3, 4. I did it. That was pretty cool. As I like to see, it's kind of like using your math and you're using logic. You're using some kind of magic. It's kind of similar to like Sudoku, but you can't use those numbers again. I've got one for you to do at home. And I want you to think about this one so that you can figure this out. And you are welcome. We're going to have these resources available to you on the APS distance learning site. So you are welcome to do that. But just as we're getting started, and before I let Miss Gaudette come up there, what's the first one that you would probably do? Yeah, you're going to do that free space. So I'm going to get that free space started for you. And I want to see what you come up with. I want to see you try it. And remember, you don't have to use, I'm using marker with mine, but you don't have to use a marker with this. You want to use a pencil so you can try out your different ideas. And I think you're going to have a great time with it. And I thank you so much. I'm going to have Miss Gaudette come up here, and she's going to work some problems with you. And hope you guys have a great day. Thanks, mathematicians.
Hello, welcome back to problem solving. We are going to move right back into Cindy's cats that we started last time. Reminder, if you haven't already done so, go ahead onto the APS Distance Learning website, download the task, or else get out a sheet of pencil and paper. Solve this before I step us through to solve it, so that you have a chance to try your thinking strategies before you hear about mine. I will be doing what I call teacher talk, meaning I'm telling you in what's going on in my mind and telling you all about it so you see how someone else approaches this task. All right, let's review. Cindy's cats. Cindy has 3 cats, Sammy, Tommy, and Susie. Cindy feeds them cat crunchies. Each day, Sammy eats 1/2 of a box, Tommy eats 1/8 of a box, and Susie eats 1/4 of a box. What fraction of a whole box does the cats eat? In all, remember those were our key words last time, each day, and then show how you figured it out. So last time, in all told us we had to do addition. So we knew we had 1/2 plus 1/8 plus 1/4. We found those equivalent fractions. And we made them so we had 1/2, and we knew we had to have a common denominator of 8. So we went ahead and said, what could we do to 2 to get to 8, which was multiplied by 4. We did the same to the top, and then on 1/4, we knew we multiplied by 2 to get that 8, and did the same to the top. So we had 4/8 plus 1/8 plus 2/8 equals our 7/8. Then we were asked for number 2, Tommy and Susie spend much of the day sleeping. Tommy sleeps 3/5 of the day. Wow, that's a lot. And Susie sleeps 7/10 of the day. Which cat sleeps longer? How much longer does it sleep each day? And show how you figured it out. For number 2, we knew we had 3/5 and 7/10, and we had to figure out which one was the bigger fraction. So we took and found a common denominator, which was 10 between the 5 and the 10, and we multiplied 5 by 2, so we did the same to the top, and 7/10 we were able to leave alone, so we ended up with 6/10 and 7/10. Knowing that 7/10 was bigger, Susie sleeps longer. Then the second part of the question says, how much longer? So we took the 7/10 minus the 6/10 to get 1/10. So our answer was Susie sleeps 1/10 of a day longer. So number 3, Cindy's cats often share a carton of cat milk. Sammy always drinks 1/3 of the carton. Tommy drinks 5/12 of a carton, and Susie drinks 1/6 of a carton. What fraction of the carton of the cat milk is left over? And show your work. So again, we were doing addition, so we had 1/3 plus 5/12 plus 1/6. Finding the common denominator, making equivalent fractions. We knew our common denominator was 12. So we had 4/12 by 5/12 and 2/12. So when we added those up, oh, there we go. When we added those up, I didn't have my addition signs, we got 11/12. And we knew we had to find out what fraction of the carton of the cat milk is left over, not how much we were doing. So we had to take a whole, which is 12/12, minus 11/12, which is 1/12. And I had already kind of circled that because of all that work. We ended with number 4, reading it through, and I had asked you to attempt it without any guidance. So let's go ahead and let's mark it up. Cindy's cats love to jump in and out of their cat door. Yesterday, the cat door was used 100 times by her cats. Sammy used it 1/4 of the time, and Tommy used it 3/10 of the time. How many times did Susie use the cat door? And explain how you figured it out. So let's go ahead and mark it up. What are the quantities that we need? 1/4. The 3/10, good, thank you. Any other quantities? I hear you shouting, it's the 100 times. That's a big information we need. What is our question? How many times did Susie use the door? And then, yep, we gotta explain. Last time I had kind of talked to you about what is the difference between show and explain. You noticed I'm showing my math thinking, my math work. And explain, when we get to it, we'll talk about that and how it's a little different. So let's look at number 4. All right. So again, I'm very big on knowing the information. So I write it down first. So I knew the cat door was used 100 times. I knew that Sammy used it 1/4 of the time. I know that Tommy used it 3/10 of the time. And I'm supposed to find out Susie. How many times did Susie use it? All right. So what can I do here? What can I do to help me set it up? I know it's used 100 times. I have a 1/4 and a 1/10 as my denominator. Let's make it out of 100. Thank you for letting me giving me the idea. So let's do our common denominator is 100. Because, how did I know? 4 can go in there. Does anybody remember how many times 4 can go in there? 4, 1/4 is a quarter, right? And the quarter out of $1 is 100 pennies. Oh, you guys, thank you for your information and input. So we know we multiplied 4 by 25 to get to 100. So 1 times 25 is 25. Can I get tenths in 100? Oh yeah. What do I have to do the 10 to get to 100? Multiply it by 10. So 3 times 10 is 30. So let me do a little bit. What am I going to do with these two fractions? Because I have to know out of 100 times. So what do I have to do? I have to add them. So let me add my fractions to get, it's out of 100 because we never add our denominators, right? So we have 25 plus 30 is 55. But I was not asked how many times did Sammy and Tommy use it. What was I asked? How many times Susie used it. So how could I use this number, the 55 hundredths, to help me figure that out? Right? I can go ahead and take that and subtract it from the 100. But I can't just do 100 because I'm working with fractions. What do I have to do? The 100 is my whole.
So let's use that as my whole. And we have 100 over 100 minus 55 over 100 would give me what? 45 hundredths. So how many times did Susie use the cat door? 45 hundredths or 45 times? Now I am running a little out of time, so you would have to explain your thinking now. That means in sentence format, paragraph format is actually the better term, you would just explain your thinking, that I knew a fourth was a quarter of 100, and moving on and just talking about and answering the question. Susie used it 45 times. All right, thank you guys for working a task with me, and we're gonna move on to Miss Carness, and you're gonna do some math and literature. Have fun.
Thank you, Mrs. Gaudette. Oh, we're gonna move a few things around. Okay. Thank you so much. We're gonna get started while Miss Gaudette takes a couple of things down. We're going to read a book today called Jim and the Beanstalk. And this is a twisted tale based on one you might already know, Jack and the Beanstalk. It's written by Raymond Briggs, and it is a book published by the Coward McCann Company in New York. Early one morning, Jim woke up and saw a great plant growing outside of his window. That's funny, he said. I wasn't there yesterday. I wonder how big it is, he said. And he started to climb. It certainly is tall, he said, as he disappeared into the clouds. When he reached the top of the plant, Jim saw a castle. I'm hungry, he said. I'm going to go to that castle for breakfast. Hopefully they have cornflakes. Jim ran to the castle and knocked on the door. He waited and waited, and finally the door slowly opened, and behind it was a very large old giant. Aha, said the giant. A boy, a nice juicy boy. 3 fried boys on toast, that's what I used to like to eat, but now I don't have any teeth. Come on in, boy, you're safe. The giant shared his breakfast with Jim. Is your name Jack? He said. No, it's Jim. Did you come up a beanstalk? Said the giant. I came up some sort of plant, said Jim. It's that beanstalk again, said the giant. It came up once before. That nasty boy Jack stole some of my father's gold and our golden harp and our golden hen, and I've never really been happy since. I can't even see to read my poetry because the print is too small. Don't you have any glasses? Asked Jim. Only drinking glasses, said the giant. I meant reading glasses, said Jim. They go on your nose and your ears. It's my eyes I'm talking about, roared the giant. These glasses are for your eyes, said Jim, and he explained about glasses while the giant listened. Get 'em, said the giant. Get 'em for me, and I'll pay you gold. I'll have to measure you, said Jim. So Jim measured the giant's head. The giant gave Jim a gold coin, and Jim climbed down the beanstalk as fast as he could. He showed the coin to his mother, and then he ran off to the eyeglass maker. The eyeglass maker could hardly believe his eyes when he saw the coin, but he started working right away. He worked all night, and in the morning, the glasses were ready. Big glasses. Jim tied them on his back, and he climbed up the beanstalk. The giant loved his glasses. He put them on and began reading rhymes to Jim. You're a good boy, he said. Now I can see you properly. I wonder how juicy you are. I can't eat anything nowadays because I don't have any teeth. Why don't you have false teeth? Said Jim. False teeth, roared the giant. I never heard of them. So Jim explained about false teeth, and the giant listened. Get 'em, said the giant. Get 'em for me. I'll pay you gold. So Jim measured the giant's mouth. Make 'em big, said the giant. The giant gave Jim a gold coin, and Jim climbed down the beanstalk as fast as he could. He showed the coin to his mother, and he ran off to the dentist. The dentist could hardly believe his eyes when he saw the coin. He started working right away, and he worked all night. In the morning, the teeth were ready. Jim tied the teeth to his back and climbed up the beanstalk. The giant loved his new teeth. He jumped up and down, chomping his jaws and gnashing the teeth until sparks flew. Then the giant sat down again and looked at himself in the mirror, and suddenly he was sad. "Ah, I used to be a good-looking lad. I had a great head of flaming red hair, and now look at me." "Why don't you have a wig?" asked Jim. "A wig?" roared the giant. "I never heard of a wig." So Jim explained about wigs while the giant listened. "Get one," said the giant. "Get one that's red and curly. I'll pay gold." So Jim measured the rest of the giant's head. The giant gave Jim a gold coin, and Jim climbed down the beanstalk as fast as he could. He showed the coin to his mother and ran off to the wig maker. The wig maker could hardly believe the coin and started working right away. He worked all night, and in the morning the wig was ready. Jim tied the wig to his back and climbed up the beanstalk. The giant loved his wig. "I look about 100 years younger," he said. The giant put on all his best clothes and danced around and around, smiling at himself in the mirror. "It's terrific. I'm so glad I didn't eat you." After a minute, he said gruffly, "Look, boy, you've done wonders, and I feel happy again, but you better go now before I get a taste for fried boy." Jim said goodbye fast and ran to the beanstalk. He slid down it and landed in a heap. Above him, the giant shouted, "Chop that beanstalk down, or I might come and crunch you up with my new teeth." Taking an axe, Jim swung and chopped down the beanstalk. At that very moment, something else landed beside Jim with a thud. It was a giant gold coin wrapped in a giant piece of paper, and on the paper was written, "Dear Jim, thank you for the teeth and the glasses and also the lovely wig. Your friend, the giant." So kiddos, as I read this book, I started wondering how big that giant is and if there was a way to figure it out. So I thought about it and I thought about it, and I started to gather some information. So I noticed on this page in the book that Jim was just about the same size as the giant's ear. So I looked up the average size, the usual size, of a boy in 4th or 5th grade, and I learned that was 54 inches. So I know the height of the boy, which means I also know the height or the length of the giant's ear, also 54 inches. But I still didn't have enough information, so I thought, I wonder how long a regular man's ear is. I found out it's about 3 inches. Still needed one more piece of information. How tall, usually, is your average man? And I found out about 66 inches. So now I think we might have enough information to try to figure out how tall the giant might be. So the first thing we need to do is think about, this is the size of a regular man's ear, are 3 inches. And what we need to discover is how many times this size of an ear, or a piece, 3 inches, will fit into the height of an average man. So this goes down to the floor. You can't see the bottom, but this is 66 inches. So I want to figure out how many times this can fit into 66 inches. So how can we do that with math? What would we use? We would divide, right? So it's 66 inches, and if we want to figure out how many 3-inch size pieces, or ears, will fit into it, we need to divide. So 66 divided by 3, it's 22 inches. There's a few ways you might have known that. You might have set a problem up for yourself, a procedure. 66 divided by 3, 3 goes into 6 2 times. And 3 goes into the other 6 2 times. Still 22. You might have also thought about 22 plus 22 plus 22 to get your 66. Or even split it up this way. 60 divided by 3 gives me 20. And then 6 divided by 3 gives me 2. So still 22. So, do we solve the problem? 22 inches? That doesn't make sense. Okay, so let's work it out. 22, 22, not inches, sorry guys, that's not right. 22 is how many times a 3-inch sized ear would fit into 66 inches. But now we need to sort it out for the giant, right? And the giant's ear is 54 inches or 4.5 feet tall. There's the size, same size as Jim. So if we use 22 gave us what you call a ratio. It's a way to compare two sizes using numbers. So we could use this same ratio to figure out how tall the giant is. So if we take 22 ears and then we multiply by the size of the giant's ear, we should get his height. 54 is a big number to multiply by. Could we change it to something else? What if we changed it back to feet? So 12 inches in a foot, 54 inches, so that gives us 48 inches is 4 feet, and 6 inches left over, so 4.5 feet. This is what we'll multiply. We could multiply it this way as a fraction, and think about it like this. 4 times 22, break it apart, gives us 88 feet this time. So 4 groups of 22, 88. A half a group of 22 gives us 11 for a total of 99 feet. We could also work it out this way using decimals, 4.5 is the same as 4.5. And we get 110 there, 88. For our same answer of 99 feet. Investigation complete. Thank you guys for listening to another story and doing some math along with it. Now we're going to play a game.
All right. Hello, everybody. We're going to learn how to play the game Farkle here in just a minute. I'm going to move this. Kind of move this chart up a little bit more so that we can use it to... Okay, so we're going to play a game called Farkle. All that you need to play this game is 6 dice. And it's kind of a fun name to say it. I just like saying Farkle. This is a game that if you look it up, sometimes it goes by zilch, sometimes it's called 10,000. But the object of the game is to get to the total of 10,000. And you do that by rolling the dice, and there are point values. So if I roll a 1 on my dice, it's worth 100 points. My 5s are worth 50 points. And then there are combinations. So 3 1s is 1,000, 3 2s is 200, 3 3s is 300, 3 4s is 400, and so on. And we're going to try to do this and practice our mental math a little bit because these are, pretty easy numbers to add together mentally. And so our goal is to get to 10,000. We're going to roll the dice. The other thing that you need to know about Farkle is that you always have to score on every roll. You can keep rolling as long as you have dice to roll, but if you don't have a scoring die on your roll, then you lose your turn. And you might lose the points that you've accumulated that far in that round. You won't lose prior rounds, but you'll lose that one. So the easiest way I think to see this is just for us to play it, and then we can talk about it as we go. So I'm going to go ahead and roll, and what I have is, I have 3 2s. Okay, good. I was thinking I didn't have anything that was scoring because I didn't see any 1s or 5s. So I have 3 2s. So 3 2s is 200 points, and then I have these other 3 dice, and I can take the 200 points and stop there for right now in this round, or I can roll these other ones. So the risk I'm taking is that if I don't roll a score on these, then I lose the 200 points. But I'm going to go ahead and try it and see what happens. Oh, I did a 3, a 4, and a 6, and so I didn't get any scoring. So now I didn't get any score on that round, and so it's Ms. Carnes's turn.
Darn. Okay, let's see how I can do. Okay, I have 2 6s, a 4, a 1, a 2, a 4, and a 5. So
your 1 and your 5 are scoring dice, and the rest of
Okay.
them are not.
okay.
So you could keep one of those. If you want to have more dice to roll, you could keep both of them.
Okay. I'll keep my 5 and roll the rest.
Okay.
All right. I get another 5,
Okay, so far you have 100 points,
and I can keep rolling, right?
and you can keep rolling if you want to.
Hope I don't lose all my points. Okay. Another 5.
So she's got 150 now, and she could keep rolling.
I think I'll stop there.
Okay, so you can be on that side, player 1. So for this round, you're just gonna write 150, and I had 0 points, right? Because I lost mine on my first round, right? Okay, I'm gonna roll again. I have 2 1s, a 5, some 2s, and a 6. I think that I will keep my 2 1s, and I'm gonna roll the others. Okay, so I have 2 more 5s. I'm only gonna keep one of my 5s and keep going because 5s are only worth 50. So if I could get like 3 of a kind out of this, I'd be better off. I got another 1, and I have 2 dice left. So now I have to decide, do I wanna keep my 350? Because I have 3 1s, 100, 200, 300, and a 50. And I think I'm gonna go ahead and keep that and stop rolling.
Ooh, good choice, I think. Okay, here we go. So, I have 2 4s, a 1, and a 5. So those all, well, the 1 and the 5 will score, right?
The 1 is 100 points. So if you're gonna keep one of them and try to leave, the 1 is the
I'm gonna
best one.
keep
probably.
that 1. I forgot the 1 was higher than the 5 last time. Could you tell? Okay, so I'm gonna keep another 1 and roll 4 more dice. I get another 1.
So here's an important thing for me to mention about Miss Carnas's roll is that each roll she's gotten a 1, so they're still only worth 100 points that way. You can't add to something that is existing, right? So she doesn't now have 3 1s, and that changes her score to 1,000.
Right.
So if I rolled 3 2s in one, I can't roll another 2 and make that a 4 of a kind. Okay.
Got it.
So that's a good thing to note.
That is a good thing to note.
You
Okay,
gotta keep going.
I'm gonna go ahead and roll these 3 just one more time. All right.
Oh no!
I lost my points.
She lost her
because I
points.
didn't roll any scoring dice on that one. So now I have a round with 0 also.
And so what we want to do also, Ms. Carnas, is I think you can total it at the end, but I think it's best to keep a running total as you're going. So you would just like stay at 150. Mine was 350 because, does that make sense?
Yes.
So instead of having a 0?
Yes, that does make sense.
Okay.
And we can keep track.
So I have a 1. Ooh, we're going to run out of time here, so I'm going to go. And I got 3 2s. So I'm going to stop with that. 3 2s is worth 200, and then I have another one which is 100. So I'm going to add 300. And so what I was talking about with the running total is 350 and another 300 would make 650. So that way we just always know from this number how close we are to getting to 10,000. And that's a good opportunity for you to practice your mental math because these are some, nice, fairly easy numbers. So we would keep playing until one of us got to 10,000. And if I get to 10,000 first, Miss Carnas gets another turn just to see if she can get to 10,000. You got to make it fair, right? But this is a really fun game. There's that little bit of risk because you could lose your points, depending on how daring you are. So 6 dice, the instructions are on our website. And we would like to thank you for joining us at Home with APS and wish you a happy summer.
Happy summer. Yay.